Welcome back. First, announcements. Number one, this week you have another quiz. The quiz is going to open at the end of the lecture and you have the full day. As usual, 20-30-minute quiz, questions all about relationship between classes, aggregation, composition, realization, inheritance, a lot of diagrams. The goal is that you understand the diagram and select some choices. Some questions are about selecting the correct diagram. Some questions are about your assignment too. So a good idea for you to review what we talked in the previous weeks about your assignment and about relationship between classes. So the previous 2 weeks in one quiz, 20 minutes, it should be easy. So full day is due today, midnight. Also, I mentioned this before. I just want to mention this again. Your midterm next week. During the lecture time, no exceptions. Next Wednesday, your midterm. I am going to talk more about this in the following lectures. I am going to give you details about the questions, about the proctoring software and so on. But please put in your schedule next week, Wednesday, your midterm. And remember, the midterm is 25% of the rate. Very important for you to start reviewing things, mainly design, relationship between classes, patterns. So review that. Final exam, some people ask me about it. So far, the plan for the final exam, Wednesday also, April the 21, during the lecture time. So basically our last meeting in the semester, the plan could be to use that for your final exam. And also you will have 1 hour and 15 minutes. Nothing, very good question in the chat. Remember, exams, both the midterm and the final, closed book. You cannot use anything. I am going to post the rules on on Canvas. In fact, I think they are there. But basically, during the midterm, you are being recorded, both the video and the audio. And the rule is you cannot use anything, and the proctoring software will not allow you to open any web page or application. So your exam, closed book, you cannot use anything. Review things. No, another good question. Today's quiz do not include patterns. The quiz, the one that is due today, is all about the previous 2 weeks. Is all about classes, relationships, the fundamental relationships, aggregation, composition, association, and so on, and good decisions about what is better to have, aggregation or composition, and some questions about your assignments, things that we review in the previous 2 weeks. For the midterm, I am going to tell you more about what is going to be included, but yes, the same patterns are going to be there, at least singleton, observer, and the ones that we're going to review this week, builder, factory, and so on. Yeah. They are another good question, sorry. The final exam is comprehensive. So the final exam is going to include everything from the midterm and more. Basically, your exams are going to be online with this Canvas tool. So the pool of questions that we're going to use for the midterm is going to be there also for the final. So in the final, randomly, you're going to have similar questions to the midterm, or even randomly, you could have exactly the same question both in the midterm and in the final. It's the same pool. The tool randomly takes questions from the pool. So it could happen that you have twice the same question. So later, my recommendation is going to be review your quizzes, and for the final, review also the midterm before you present the final exam. So by now, please review what we have been covering in the lectures, review your quizzes, review your homeworks. You still have a little bit more than 1 week. Any question, let me know. Good? Okay. March 10, April 21. Put that in your schedule, both during the lecture time both 1 hour and 15 minutes. The exam is 1 hour, and basically my goal is that in 15 minutes, you can set up everything, because the software that you're going to use for the proctoring is going to ask you for your ID, for taking a picture and some things. I am confident that you can do that in 15 minutes. In fact, most of the people do that in 5 minutes. So you have these 10 minutes that you can use to review your answers. But so moving forward, patterns. We were talking about the quizzes should be available. If by any chance they are not, or if you cannot access one of them, send an email to the TA and she can enable that for you. Probably yes. I have a question about assignment 3. So yes, probably assignment 3 is going to be due after your exam. I'm going to recommend you to study some things, but probably the assignment, the practice, the big one. Assignment 3 is all about patterns. Assignment 3 is going to be put together several different patterns. So probably I am going to ask you about the assignment. I am going to tell you more about the assignment, but it's going to be due after your exam, even though some patterns are included in the exam, probably separate patterns. Later, what is going to happen is that we put all together in one program. Good. Okay, so moving forward, talking about patterns, we was talking about Decorator, and hopefully you have the opportunity to review the source code that I shared with you, showing Decorator. Hopefully at this time you remember the features that are important in Observer, the features that are important in Singleton. Moreover, the features that are important for the Decorator. Talking about the Decorator, I want to review this one quickly with you before moving forward with other patterns. When you have a problem, and that problem includes having an object, and that object is going to have kind of childs, subversions with particular extra elements like student, professor, person, professor, person, students, these extra elements. You have the option to use inheritance, or you have the option to use Decorator. When we use inheritance, when is better to use Decorator? Do you remember? Inheritance versus Decorator. What is the key thing that helps us to select between one or the other? Runtime versus compilation time. In particular, can you help me? What is this thing in runtime that inheritance provide that obviously Decorator cannot? One of the principles, maybe the most important in object-oriented. Yes, that one. Key idea, guys. I am not giving you a rule like a recipe, but key idea. If you need polymorphic behavior, obviously you need inheritance. So forget about the Decorator. You need polymorphism. You are planning to do a data structure. The data structure is going to store professors and students, and you want them to behave polymorphic. So you can do this array or linked list or whatever of persons, and then have the both of them. If you need polymorphism, you need inheritance. So forget about Decorator. If you need to do decorations, if you need to add something to a core object, and you do not need polymorphic behavior, it's not something that your problem needs, probably Decorator is your best choice. Example that I give you, this particular software. I am going to show you this with pictures, but I am sure that you can think about this with behaviors, with extra methods or extra variables. The only reason for me to use pictures is to make visible the result. What if I want in real time to create objects that could be only this guy, that thing alone? If I press this bottom there, what I am going to have on the screen is this guy. But if I press this here, what I am going to have is that guy and this yellow box. Or if I press this, what I am going to have is this guy and this picture, 2 pictures. Or if I press this one, I am going to have the 3 of them. And again, I am thinking about pictures. It could be methods, it could be variables, real time, runtime. I press one of these options, and what I get is an object, and that object is going to have one or more things from this collection of images. It's a problem that is asking you for decoration. It's a problem that is telling you, you know what, this is the original guy, and we want to decorate with this, or with this, or with both. Decoration. We can start with a class diagram. Class diagram. It is very important to remember that the patterns, any of them, singleton, decoration, observer, later factory builder, and others, they are used one block. Like if you think in a Lego, is just one of the blocks in a full model. And the full model is your class diagram. In this example, what I am trying to do is to solve this problem. And in order to solve this problem, yeah, I think that I need decorator. And the decorator pattern is the classes that I put in yellow. If you check the yellow boxes, those are the classes that correspond to the class diagram that I showed you for the decorator pattern before. However, they are going to be connected with other classes that could be other patterns, or could be used classes alone, classes that I need to complete my program, my system. In this example, what I am asking you is to do a piece of software. That piece of software obviously need a main method. I am going to put my main method in one class, a class that is not part of the pattern, because the pattern do not have a particular space for the main. The patterns do not have mains. Moreover, what I am asking you to do is a graphical user interface. Probably this main, according with our experience with the project that you have done, by now could be obvious that this main is going to be a JFrame. Moreover, by now it's obvious that the relationship between JFrame and the main is going to be inheritance. It is better inheritance than composition or aggregation. And if main is going to be the frame, and I want to put something inside, by now you know that the best thing that you can do is to put panels inside. I am going to need something that is a panel. And if you notice, my 2 classes in blue are the ones creating the graphical user interface that I need. Now, inside of the panel, inside of this class, what I am going to have is this idea of this guy, or these 2, or these 2, or the 3 of them. This one is the one that need to use something that is the top of the decorator pattern. This guy, the panel, need to have inside these elements. And those elements, the best way to connect them is with the decorator philosophy. A core element, decorations, and then in real time, we can put together 2 or 3 of them. Did you notice the connections? We do not need to have crazy connections, like everything connected with everything. Few connections are better. Moreover, in the same way that your source code should be easy to read, your design should be easy to read. Now, the important thing is this design should be able to become source code, and the source code should match with this design from the beginning and later. When we finish the programming and we go back to the diagram, they should match. So far, if I think about my diagram, it's like, if I can put this in source code, I like this solution. Very few connections. Most of the connections are because of the pattern in the yellow classes. And for everything else, only 2 connections and only 2 extra classes. If this diagram can become this application, it should be easy to understand. The reader, think about it. The only thing that you need to understand is 1 connection, 2 classes, and everything else is a pattern, which is standard. Source code. Keep in mind the diagram. For the source code, we can start for the first time. I am going to start here. I am going to start with the main. Because we before work with the pattern, so I am sure that you expect something in the pattern. Let's start with the main, top down. With the main, according with the graphical user interface that I showed you before, this one, you know what you expect. A panel there, 1, 2, 3, 4 buttons to click. Probably listeners are going to be involved. Good. Let's see. My class, main. Main, extend, frame. We already showed that in the class diagram. We're going to have this click in the elements, in the widgets. We need the action listener. We need the action listener. It could be a very good idea that I go back to my class diagram, and you know what? This guy is going to use action listener. Action listener, the relationship, a triangle there. And hopefully you agree with me. Oops, opposite. Hopefully you agree with me. The line should be dot. Is realization, not inheritance. So inherit from JFrame and implement action listener. That is what I have in the main. That is what I have in the source code. Now, talking about the elements. Well, first draft of the source code, I need 4 of these. 4 keyboards. And do you remember this line? I need that line. And I have here a diamond. And moreover, but I put this a black diamond, so that one. I need 4 widgets, and I need this connection with a panel. This is my class. Later, you are going to notice we inherit JPanel. You can be thinking, well, in the diagram, you are missing this class. Okay, I can put the class. What is the relationship between main and the class JBottom? It's a solid line. But moreover, it's exactly the same that between main and companion panel. According with the source code, that is what I have. Probably not the best idea, but again, my diagram and my source code match. That is what I have. Black diamond between the panel, black diamond with JBottom. If you want to be more specific, remember, you can put a number here. I have 4, so I do not need 4 lines. You can put 4 lines. It is better to put the number, clear, easy to read. 4 widgets, 1 panel, done. Good. What else? I have a constructor. Something happening in the constructor that is important. Something happening in the constructor that is kind of new, crazy, that we need to review. Hopefully you agree with me. Nothing. Trivial creation of a graphical user interface. Just adding the elements. to the screen. Probably the only thing important, adding the listeners. I am going to use, Alvin in the chat, I am going to use these names in the action perform method. That is the only reason, because they are global. It could be better to define these names as constants, but I use less space in this way. So that is the only reason, because they are global. I am going to use the B1, B2, B3, B4 in another method in the next slide. If not, I can move this here. And I think we talked about it. It is better to have local variables. So it could be possible, and something that you can do. B1, B4 can be moved as locals in the constructor. But what used to make easy to read my example, they are global. So you can remember them, and they are available in all the methods. Constructor, just creating the graphical user interface, nothing really happening. You are adding the panel. You do not know what that panel is going to have. It's just, okay, I am going to use this class. I am going to put that class in the center. I don't care what is going to be inside. I don't care that the decorator is going to be used. I just creating the graphical user interface for a system that is using these widgets and this panel. Good. The action performed. The method that is going to be executed when you click the bottom. Did you notice what is happening? And here is where I am using B1, B2, B3, B4. Did you notice what is happening every single time that I click one of the widgets? Every single time that I click one of the widgets, you can notice I am creating the core object and I am creating the decorator objects. If I do not need decorators, I do not create anything, use the core. If I need one decorator, I create that one. If I need two, I create two. Two, one, nothing. The user click a widget. In the listener, I create one or more objects. And the only thing that I do, connect them, connect them, connect them, connect them. Decorate. Real time, runtime. When the user click, the objects are created, the objects are connected. Next click, new values for the objects, new connections. In the previous examples, the decoration happened in the main and never change. What I am showing you here is, according with what the user do, you change the decorations, runtime. That is the reason for the pattern. Other than that, the main, obviously, nothing new here. Nothing that we haven't done before. Create the new object, configure the object, run, show everything. And why not? Make the object close. This is main. Don't. Main is working and doing everything to set up the application. And I do not care about the panel. I do not care about what is all this basic companion, helper, affected. Create the object, connect the object, what is going to happen? I don't care. I am using Lego blocks. Moving forward, well, okay, this is the main. If I want to continue with this idea, my next class could be this one, the one that I am using with the main. Okay, that one. that one should be a panel or something in the family of the panels, remember? A place in which I can do something. For this particular example, I will use a panel that is this guy. It's a child of panel. Help me, do you remember what is the particular feature of that panel? Layer pane. It is a panel with one particular property. You can have several different layers in that panel. I am going to use that for the drawing. One draw here, another draw here, and maybe another draw in a third layer. And I can have the three elements in different layers. So I do not need to draw from scratch. I can use overlap different pictures in one. But again, this is just programming for the particular scenario, for this guy that is going to be the one hunting the elements. What do we need? Well, according with this, what I am going to do is to provide some methods with the panel, provide some method. Probably the only one, the important one, is that one. That one is the one that I am calling every single time that the user click one widget. Every single time when the user click some option, I am calling this method. This method. What happened? Remove all. I am a panel, remember? And from the class panel, I inherit this method because it's not a method in my class. And that method is going to remove everything that this panel has. If you add something before, it's going to be deleted. It's going to clean the panel. Everything, every time that the user click the widget, the first thing that I am going to do is delete everything, clean the screen. After I clean the screen, just because I clean everything, the second thing that I am going to do is to put again the layout. The layout, again, is one by one. It's only one column in one line. I delete everything, so I am going to put this again. I am going to put that again, and I am going to call this method. This method from who? This object. That object where? In the top of something, and that something is this family for the decorator. I am going to ask for the method that is equivalent to operation, that operation that we reviewed before in the template. So every single time that the user click one of the elements, I clean the screen. After I clean the screen, I establish one by one, just to make sure that the full screen is used. And I call the method operation in the top of the decorator pattern. Do something, the operation. And this revalidate that this kind of the repaint. So go do whatever the decorator do. And when you finish, just make sure to repaint the panel. Done. A frame with a panel, with the listeners. When I use the listeners clean the screen and call the decorator. And that is what is happening in these classes. The core, the work, the real work. If this do something, the real work in the decorator. What is going to happen in the decorator? Well, all these images that I want to show. Let's review. Decorator. Now we need to review this. Let's go top down. Top down. The first thing that I have is this companion. And companion, as you remember, the only reason for that one is to be the parent of the full family. It's going to be an interface. It's going to be the place to put a method without body. This method do something. And by the way, do something need to receive parameters. In the original template, we do not have parameters. There is nothing that tells you that you cannot include parameters or more methods. Remember, it's just a template that you customize for your problem. The template gives you a method that is going to be in all the classes in the family. If that method needs a parameter, like this one for the graphics, I can use it. And this do something from the companion. And I want you to notice, this one is the interface. I am using the interface, the parent. The method is empty in the interface, but we're going to put a body to that method in the childs. And I am sending as an object this. Remember the listeners. How many times you do add action listener, parentheses, this. This, the panel. Here, I am going to receive a panel, a J component. Remember, the hierarchy for the panels is the parent of everything in J component, and then you have the panels, and the panels you have the diversity of panels. I am receiving the space in which I am going to draw. Well, this is just the interface. This is just this guy. Nothing. Moving. The childs. I have two childs. The first one is going to be the child that defines the core element, the element that is going to be decorated. Name of the class, implements, because the parent is an interface, basic companion, implement companion. What should I do in that class? Override the method. Which is the name of the method? In this case, we're calling the method do something. Moreover, in this case, we're passing a parameter. Override the method with the parameter. And here is the place in which I am going to draw the guy, the core. Remember this, something like this. That is the core, the one that I want to decorate, the person. An icon, new object, is going to be an image. I am going to put that one in a label, and I am going to position the label in the screen in a particular place. I am going to put some text. It's a label, so this is a label with the image, with the text, and the only thing that I need to do is to add the label to the panel. Which panel? The one that I receive as a parameter. The main with the frame, the panel, the decorator. The decorator receives a reference to the panel. The decorator can draw in the panel. And this one is the core. That one is the one that is going to draw this guy. Okay, what about the decorations? I am sure that you can imagine what is going to happen with the decorations, because it's almost the same that this class, almost. The big change is going to be this line. Number one, the panel of the decorators. The panel of the decorators, one class, is also going to implement companion, the parent of everything. And this one is going to implement this connection, the one with the diamond, this object. I need a method to add this object to provide a value, the classic add something. And we need to override the method do something. And as you remember, this is the key part. This is the part in which this guy in the method do something. What it's going to do is to call the do something of the object or objects that this one have inside. This is for the template. And all of this source code that we described before in the template of the decorator pattern. Nothing here is for solving my problem. All of this is copy paste from the template. Things that we reviewed before, we know why they are there, but they come from the template. Done. What about this? The two decorators that I need to solve my problem. Well, number one, the effective. Extend the companion decorator. The only thing that I need to do, override the method. Override the method. The only special thing that I need to do here, and is for the template, call the super. Call the do something from the parent class. We did that in all the examples that we have reviewed. It's part of the pattern. After doing that, all this is up to your problem, up to the problem that you are solving. In our example, again, a new icon with a new picture, a new label. In the label, the icon, and we can add some text. And basically, this is going to draw the party thing with this. Notice, it's only the decorator. There is no small subject here. There is not a person here. The person is drawn in the other class. The person is the core. This is just the decoration, the party thing with the message cherry. Exactly the same idea for the other class. Helper, decorator, override the method, call the super, and here, everything the same, different message, different image. This decoration is the one that have something like this with help. Decoration for help, whatever. Decoration for cheering, whatever. And the original guy, the person. 1, 2, 3 things in 3 different classes. 3 different programmers can be working in all these elements. We have everything. The task is split in at least 3 programmers, 5 programmers, 4. Someone working in the blue classes and 3 people working in the core and the decorations. And the connections, you do not need to worry about the connection. The connections are in the pattern. For the connection, you just follow the pattern, exactly copy paste the source code. And this is everything that you need. If you copy paste the source code, what you need is this program working. Click here and you have this guy on the screen. Click here and you have this guy and this globe. Click here in the last one and you have all of them. If I ask you to modify the guy, or if I ask you to modify the message, or if I ask you to do more decorations or different decorations, hopefully you know exactly what to do. New classes that maybe are going to inherit from A or B. You don't need to start from scratch or spend hours thinking about how to do something. Hopefully this is clear. Questions? Okay, decorator, singleton, and observer for sure in your exam, and hopefully before that in another quiz. But in your exam, for sure, you should know these three, what they do and how they do it. Class diagram and source code. Review the class diagram, review the source code, and be sure that you understand how to map one to the other, the key elements of those three patterns. And your assignment 3 for sure is going to use them. Moving forward, something that I want is to review at least 2 patterns in each category. Now you know one of each category. Let's review more, and let's go back to the creational category. Why this one? Because the one that we review, the singleton, to be honest, was too easy. So let's review something else, a little bit more interesting. So singleton, you use the singleton when you want to create one and only one object from a class. Let's review the builder. Question in the chat for the observer. In your exam, there are going to be questions asking you to implement the observer with the Java util classes. And there are going to be questions asking you for the original template. So be prepared to use any of them. Common error, for some reason, in some questions in the exam, I asked you to complete the program using Java util.observer, using the Java library. And for some reason, a very common error is that you, the student, implement from scratch the observer. So I do not know if it's about memorizing things or something, but read carefully. If the question asks for using the implementation in the Java library, do not repeat the classes. Do not put everything again. Another common error is to do both. Implement the classes and use the libraries. Review that. You only need one. And we are going to tell you which one we want. Builder pattern. Let's see. What is the goal of the builder pattern? We need to create an object. And option number 1, you use the new. And you call the constructor. And for the constructor, you pass parameters. Right? That is the way that you create an object. What happened when, in order to create the object, the number of parameters here is too big? You need a lot of parameters. If you just do the new and call the constructor and pass all these 100 parameters on 20 parameters on 10 parameters or whatever, reading this is going to be very, very complex. Remember, according with the good practices, you have a limited size for your screen, 80 characters. So if you think about a constructor in which the parameters are going to be more than that, probably you need a builder. Again, you are going to create an object. The object needs a lot of parameters. The parameters do not fit just one call to the constructor. A builder is an option. Moreover, sometimes it's not only the size, but also the fact that probably one of these parameters or two, you already have it, like variables that you receive or variables that you create. But for others of those parameters, you need to do some kind of process to get the value and later use the value as a parameter for this new object. Some of these parameters could be complex to create by itself. So when that happens, when the number of parameters is big, or when the parameters itself are complex to create or complex to get, that are two indications of Builder is a good option. Builder. Class diagram, kind of easy. The only thing that I am going to do is this object, the object that I am creating, is going to be called the product. And there is going to be another class taking care of the parameters. And that other class is the one that we are going to call the builder. But these are patterns. And as usual, this is what I want to create, the product. And I am going to have a builder. The builder is the one that is going to create the object. But as in several other patterns, we're going to have the builder, the class, but also we are going to define an abstract class, or better, an interface for that builder. In particular, in Java, it's going to be an interface. A list of the methods that the builder has without the body, and in another class, an implementation of those methods. The interface and the class, the builder or abstract builder, and the concrete builder, or use the builder, connected with a product. This is my builder pattern. Now, as usual, the builder itself do nothing but creating objects. Someone is going to be the user of this builder. In the original pattern, in the one that you can find in the book, the user of the builder is a class, and they identify that class as the director. So we have the director using a builder, or more than one, and you have the builder, the interface, the class, and that one is the one that creates the product. Builder, product, and director. This is the original one. And the first thing that I want to do is to show you the source code for the original one, and then show you the improvement of the original one. That is the one that we use today, really. Patterns, the book, this one, remember, 97. A lot of things can be done to implement it, to improve this. But let's review first the original one, then we move to the improvement. For the original one, for these classes, for this diagram, source code, kind of easy. I am going to have a class. In that class, I am going to put the main, and just to change the stimuli, the class with the main is client. Any name. Tell me, this is my pattern, and this is the class that I am showing you on the screen. Which are the connections between the class that I am showing you on the screen, client, and the classes in the pattern? There is one connection or more than one, and which are the connections? Aggregation, composition, association, inheritance. Question in your exam, question in your quiz. Can you connect client and the diagram of the pattern? How many lines and which ones? There is a connection with director, right? So this one is connected with this one. I think so. Which is the connection? Composition, aggregation, association, realization, inheritance. And basically what I am asking is, which is the arrowhead that I need to put here? And it's always a tricky question because there is always this new here. And because we have the new, we can think about composition. However, the variable is global or local? It's inside of a method, right? Local. And if we have the variable local, what is the relationship? Composition or association? The question is in your quiz, by the way. Association, yes. The arrow, pointing down or pointing up? Pointing from director to client or from client to director? Okay, client to director, down, right? Remember, the arrow is going to go out from the user. In this case, the user is client, and is going to be pointing to what is being used. And in this case, what I am using is a director. Client is using a director. In fact, it's the same relationship that you could have between a professor and a student, bidirectional, student to professor is the same, using, because we're going to call a particular method. That one is really the reason of the arrow. How many more lines do I need according with this source code? Can you agree that basically it's going to be the same arrow and it's going to be connected with Student Builder and Instructor Builder? It's going to be connected. Well, I just put the pattern diagram there, but what I am going to do is to have Builder, and I am going to have the student one maybe, and I am going to have another one, and the other one is going to be the instructor maybe, and then the client is going to be using this one, and it's going to be using that one, something like that. One director, two builders. Good. In this particular program, director, director, and I am sending to the same director the two builders. Think about this. I am hiring a director and I am hiring two workers, and basically I am connecting the director with the two workers. It's like I create all of you, I hire all of you, but then I am going to tell you, you two are going to work with this one. Bye. Calling methods. Okay. Again, this is not part of the pattern. This is part of the program that I am doing. The pattern is what I have down. This is just my program, a program that I am using to see what happened with the pattern. Good. So I have my client, a program with three objects, and I am calling methods in those objects. Something is going to happen. Moving to the pattern. In the pattern, class number one, director. Director is a class, not an interface. And according with this, well, director is going to have this method. And the only thing that director is going to do is to put the builder to work. For this example, the classical example of the pattern, what you have is a builder, one of these guys, and what you do is call the methods that together replace the constructor. And which are those methods? The setters. What can I do instead of calling the constructor with a bunch of parameters? Call the setters one by one. In this scenario, I am calling the setters one by one with only integers and strings, nothing fancy. I am going to show you another example a little bit more fancy, but this is just to give you an idea. The role of the director is to call the builder. The role of the builder is to receive the calls to the setters for the product instead of calling directly a big constructor in the product. Obviously, you can have several builders in a director and you can have as many setters as you want. Okay. Nothing important here, nothing fancy. What about the builder? Nothing fancy either. We need a parent, the parent. And the only thing that the parent is going to have is an interface. And the interface is going to define all the methods that we need or want in that builder. In this case, all the setters that we need to have available publicly for the director to use. And what is going to happen with the builders? They implement the interface. When they implement the interface, I can be sure that they are going to have the setters. And the only thing that they are going to do is to provide the body for the setters. The body, anything fancy, just a normal setter. The setters store the information here in local variables in the builder. Wait, those variables should be in the product, not in the builder. This is the important part. This is my product. And just imagine that the product has two variables, X and Y. What I am going to do is to have another class that is a builder. And that class is going to have exactly the same variables. Exactly the same. And what is going to happen is I am going to give data not to the product, to the builder. For instance, I am going to give a value to the X, but the Y is still empty. In some point, I am going to give a value to the Y. And when I have all the data, when this builder has all the data, this guy is going to create the object, the real product, in just one step. That's it. So are you telling me that what you are doing is to create another class that is a wrapper for the product, and this wrapper is the one collecting the information, and when the information is complete, then in one step you create the product? Yeah, that's it. For what? Easy. Can you think about an object student? In the university. An object student. Well, the interface is this. Well, the interface can be the same for all the builders that are related with the same problem. For instance, you can have several builders for students, and all the builders that you have for students should implement the same methods that we define in the interface. So the idea is that you can have more than one builder as far as you can implement the same methods. So yeah, But if the builders are builder for student and builder for professor, you need two interfaces, the interface for the student, the interface for the professor. What happened with the student in the university system? You cannot create a student if you do not have all the information. Maybe the name, maybe the ID, maybe think about all the information that is connected with you. In the system, you are an object. In the system, there are information about you. And in order to enroll you as a student in the university, there is a set of information that we need to have. We cannot create an object and therefore giving you an ASU ID without a set of information that you need to provide. But maybe you can provide that information, not everything together today, but maybe submit something today and submit something else that you need to collect later and something else later and so on. Maybe I can know your name today because you are enrolling and submitting a particular form, but maybe there are information about payments that you need to do next week or in 2 weeks. So I cannot create an object student, but creating the object means that you exist in the system. And I cannot create you until I have all the information from you. What I have is a builder, and I create a builder that is connected with you. And this builder is going to collect the information about your name and family and so on. And this builder is the one that is going to be there waiting for the extra information to arrive, payments and so on, whatever. And until we have all the information and you are officially a student, this builder, this wrapper, this temporal object is going to put all the information in a student object. And in that moment, you have an ASU ID. You exist in the system because the object, the student, have been created. The builder was just a wrapper, a temporal place for the information that until we have completed, we cannot create a product. That is the philosophy for the builders. In the builder, that is the philosophy. You can set variables in any order. Probably this is a copy paste, so they are in a particular order, but any order in different classes, in different moments. This example is just setting all the variables. Again, use a vanilla example. But the idea is you can set the values in the builder, in any moment, in any order. The key idea is when all the values are there, then you can do this. Call a method that is going to do the new of the product. And that method that is going to do the new of the product is going to pass everything as a parameter. A wrapper for the product, a temporal storage for the partial information until we have everything and we create the product. That's it. Builder. Builder for student and the same idea, builder for instructor. Good? Now, this is the original one. Class student, class instructor, and as you can notice, the same variables. And with the classical setters, getters, and constructors. The product do not have anything fancy. This one is kind of the original idea. However, I am sure that you are more familiar with this one, the Fluent Builder. Let me be clear. The previous one, the builder, is the one that you found in the book, The Gang of Four. This one is the evolution of the previous one. And you know what? This one do exactly the same that the previous one with one extra thing. method shining. Can you help me? What is that? Are you familiar with that? This thing here? Maybe you know something to create neural nets. This is just an example. But maybe you are going to have something like this. What is happening here? I want to create an object. I want to create an object and I am using a new. But instead of passing here all the parameters, because I want to create a neural net, but my point is you want to create a neural net and you need to pass as a parameter how many layers do you want. And inside of each layer, there is information about how many neurons and the functions and blah, 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 blah. A lot of information, but the point is I cannot create an object neural net without all the information about all these layer, neuron, function, blah, blah, blah. It's a lot of information for a constructor. And what you're going to have is that you are creating an object here, and there are several lines that for some reason have this builder build keyword, and you have several lines starting with a dot. Every single time that you read something like this, what is happening is you are using the builder pattern, or the Fluent Builder pattern. How this thing works? Let me go back. This is what I am doing. Instead of the parameters here, I create the object and then I call the setters. Let me be clear. You are doing something like an object. You have a class equal new object. And instead of sending parameter 1, parameter 2, parameter 3 in the constructor, what we are doing is something like object, whatever, equal, new object, no parameters. And then set something, P1, and set something, P2, and so on. The advantage of this, the only advantage of this, is that you can split these setters in several lines, and therefore having something like this that is easy to read compared with open parentheses and a bunch of parameters. And when you are done, when you have your builder with all your parameters, what you can do is to call a method get in the builder, and that one is going to give you the product. In only one line, you get the product. In several lines, you configure the builder. And again, I am giving you the example with all this set in the same place, but they can be in different methods in different places of the program. When you are done with all the variables, you call the get. What do we need to do, programming, to make something like this work? What do we need to do to make a program like this work? Can you imagine what do I have in this class, Fluent Builder? Number one, I need my interface, always. My interface the only thing that have is the methods without the body. Setters. By default, the setters return something, yes or no? Yeah. Setters by default. Let's go back here and setters. Setters are void, right? Getters return something, but setters are void by default in Java. Exactly. What I am doing for the Fluent Builder, what do we return with the setters? The same type as the class, right? We're going to use the this. This is the interface. The interface is telling you that you are going to have setters, but when you implement the interface is going to make you to do setters that instead of being void, return something, return builder in this case. If I implement the interface, can you notice the difference between the traditional ones? Instead of void, builder, and builder is the parent. And instead of just doing the set, return this. And by returning this, we can do all this method chaining. This new is going to return this. Therefore, I can call the setter. The setter is going to return this. Therefore, I can call another setter. It's going to return this. Therefore, I can call the other setter, and so on. In any order, always it is possible to call another one, because each method is returning the object. And you can imagine in this example, what is happening. These ones, this one, this one, this one, this one, all of them, like the setters, they return an instance of the same class or the class layer. You can be configuring the net, and you need as a parameter a layer, and you can configure the layer inside the net, the layer. Are you familiar with any other example, any other library in Java in which this pattern, the Fluent Builder, is being used a lot? Yep. Have you had the opportunity to review streams? The use of the Fluent Builder is very extended. Again, when you have these dots, you are using the Fluent Builder. A modification of the original one with this return this. Good? So, any questions so far, guys? Builder and Decorator. Okay, I am going to stop here. Next lecture, we review the factory. Remember, you have a quiz. The quiz should be open by now. It's due tonight. Good? See you next lecture. Thank you.